All right, I had a student request about this one. This is a circle inside of a square, right? The circle fits snugly inside this square, and your job and your objective is to find the area of the shaded region. All right, so when you look at this shape, the bigger of the shapes is the square. The square is the bigger of the shape, okay? And what happens is the circle sits inside. The circle's area is less than the square's area. So the goal and the objective here is, if you had this on a piece of paper and I ask you, what's the area of the shaded region, you could simply take a piece of a pair of scissors and cut the circle from the square. What's left over would be the area that you're trying to find. And remember, you're cutting out, you're subtracting, and that's the key. So the first thing that you would do is calculate the area of a square. Well, if a square has a side that's 12, then the area is going to be 12 times 12, and 12 times 12 comes out to be 144 for the area of just the square by itself. Now, when you go and you calculate the area of the circle of circles are found by taking pi r squared. And remember what that means. That means pi times the radius times the radius. Now, 12 is not the radius. 12 is the distance all the way across this circle. What I need to know is I need to know halfway across it, so the radius is going to be 6. So now what I need to do is apply this math formula right here and calculate my area of my circle. So I do 3.14 times 6 times 6. And when I do that, I get 113.04. Now it checks, it makes sense, because obviously the circle had to have a smaller area than my square did, okay? Because the circle fits inside the square. So now all I have to do to simplify this question is take the area of the square, 144, and subtract, cut out that circle from it. So minus 113.04, and what's left over is 30.96, and since it's centimeters, it's going to be centimeters squared, because that's what we're finding. We're finding an area. So 30.96 centimeters squared. And this is how you calculate the area of a shaded region when basically two shapes are almost overlapping, okay? This is referred sometimes as a circle inside a square type of problem. I hope you found this both helpful and informative.